For nearly 4.6 billion years, a story has been unfolding. It is a chronicle of immense violence and profound silence, of catastrophic upheaval and the slow, patient emergence of stability. This is the biography of a world, our world, a mysterious blue marble, adrift in the cosmos, and, so far as we know, the sole vessel for conscious human life. To comprehend this chasm of time, we must compress it. Imagine the entire history of our planet condensed into a single 12-hour span. The moment of its formation is midnight. The present day is noon. Within this cosmic clock face, we will traverse 4 great eons: the Hadean, the Archean, the Proterozoic, and the Phanerozoic. The clock begins. It is midnight. The Hadean Eon. 4.54 billion years ago, our solar system was a spinning disk of gas and dust, the raw material left over from the ignition of the sun. In this swirling chaos, cosmic grains began to cling to one another, their mutual gravity a weak but persistent summons. Over millennia, they grew, forming solid bodies known as planetesimals, the first seeds of future worlds. These primordial objects, some measuring miles across, engaged in a gravitational dance of creation and destruction. They collided, merged, and grew, sweeping the orbital paths clear of dust and debris, forging planetary embryos from the wreckage. Distance from the nascent star dictated destiny. Far from the sun's heat, colossal cores of rock and ice took shape, their gravity immense enough to pull in the vast clouds of surrounding hydrogen and helium. They collapsed in on themselves, giving birth to the gas giants, Jupiter and Saturn. Farther still, Uranus and Neptune formed smaller titans unable to hold on to the primordial gases, leaving them as frozen worlds of rock and ice. Closer to the sun, in the inferno of the inner system, the telluric planets were forged. Composed of rock and metal, their early lives were a brutal contest for survival. Their orbits crossed in a cosmic demolition derby, a process of violent elimination that left only 4 survivors: Mercury, Venus, Mars, and a still glowing molten sphere of rock, the proto-Earth. This entire planetary genesis took 100 million years. On our 12-hour clock, it is now 6 minutes past midnight. A rogue world, a protoplanet astronomers call Theia, has been wandering the same orbital path as Earth, a ghost in the young solar system. For a time, it existed in a stable, shared orbit. But stability, in this era, was a fleeting illusion. In the grand gravitational ballet of the early solar system, a rogue world, swollen to the size of Mars, is wrenched from its path. Its name is Theia. Its orbit, once stable, descends into chaos, pulling it onto an inescapable collision course with a young molten Earth. 4.52 billion years ago, the two worlds meet. The impact is a cataclysm of unimaginable scale. Theia's dense iron heart plunges through the proto-Earth surface, sinking into its very core. A colossal spray of vaporized rock, the remains of Theia and a vast portion of Earth's own mantle, is blasted into the heavens. For millennia, This ring of incandescent debris encircles our wounded planet until gravity begins its patient work, drawing the fragments together, coalescing them into the familiar sphere of our moon. But this is a moon our eyes would not recognize. It hangs in the sky just 22,500 kilometers away, a colossal lantern in the primordial darkness. Its immense gravitational pull locks the Earth's chaotic spin, stabilizing its axis. Yet this proximity comes at a cost. Powerful tidal friction acts as a brake on our world's rotation. A day lasts a mere 6 hours. A year hurtles by in 1,434 sunrises. 60 million years after the moon's violent birth, the Earth remains a world under siege. A relentless bombardment by smaller celestial bodies continues to scar its surface, each impact releasing a torrent of heat. This kinetic fury, combined with the fierce thermal energy from decaying rubble to cool, the world's rock melts into a global, seething ocean of magma. From this homogeneous, fiery state, a new order begins to emerge. Under the relentless pull of gravity, the heaviest elements, iron and nickel, percolate downwards, sinking through the liquid rock to accumulate at the planet's center. They form the dense metallic core. The lighter elements, the silicates, are left to float on the surface, slowly shaping the vast layer we call the mantle. Gradually, the surface of this magma ocean begins to cool and solidify. A thin, brittle crust forms, cracking and fracturing into vast plates, the seeds of future continents. Adrift on the still liquid mantle below, these fur. 10 million more years pass. Deep within the planet, the churning of the liquid metallic core generates powerful electric currents. A dynamo whirs to life, giving birth to an immense magnetic field. This invisible shield envelops the planet, a guardian against the solar wind, a constant stream of charged particles from the sun that would otherwise strip away the light elements essential for life. Protected by this magnetic aegis, an atmosphere can finally take hold, and the first delicate sparks of biology are shielded from cosmic radiation. By 4.4 billion years ago, the Earth is settling. Its surface, a scarred and alien landscape of craters, towering volcanoes, and jagged mountains, slowly radiates its primordial heat into the blackness of space. This violent, chaotic world was not a wasteland. It was a crucible, forging the very foundations upon which all subsequent creation would depend. The young Earth is a world in conned, superheated steam, trapped deep within the magma. For eons, the surface temperature was so extreme that water existed only as a suffocating vapor in the primordial sky. But as the planet slowly radiates its formative heat, a critical threshold is crossed. At 350 degrees Celsius, under immense atmospheric pressure, the vapor begins to yield. It condenses, and then it begins. The first rain, not a gentle shower, but a planet-wide torrential deluge that will last for millennia. Countless molecules of water, once atmospheric ghosts, become liquid, falling in an unending torrent. The deluge carves its way through the barren, rocky landscapes, cascading down crater walls, pooling in the vast depressions of the crust. Over 50 million years, this relentless accumulation will give birth to the first global oceans. This watery world enters a new eon, the Archean, a chapter spanning 1.5 billion years, a period that will be defined by cosmic violence and ultimately by the first tentative stirrings of life. 4 billion years ago, the heavens turn against the nascent planet. A period of unimaginable violence begins, known as the Late Heavy Bombardment. The cause lies in the outer solar system. The gas giants, Jupiter, Saturn, Uranus, and Neptune, are shifting in their orbits, a gravitational dance that destabilizes a vast belt of primordial debris. Countless planetesimals are flung inward, careening toward the rocky inner worlds. The surfaces of the Moon, Mars, and Mercury are forever scarred, and Earth is directly in the line of fire. Asteroids, some 1,000 kilometers across, the size of a modern nation, slam into the planet. The energy released from a single impact is enough to vaporize vast sections of the newly formed oceans, boiling the seas back into the sky. Yet, through this cataclysm, the essential ingredient for life endures: liquid water. Life, as we understand it, requires a solvent and a source of energy. Water provides the medium, the sun provides the power, and the earth, a crucible of chemical potential, offers the stage for simple organic molecules to react, to combine, to evolve into something extraordinary. But 3.8 billion years ago, the sun was a fainter star, its energy output 20 to 30% lower than today. Under our current atmosphere, this faint young sun would have doomed the planet to an eternity of ice. What saved this world from freezing was its atmosphere. A thick, heavy blanket of greenhouse gases compensated for the sun's weakness. With no vegetation to process it, carbon dioxide levels were 10 to 100 times higher than they are today. Oxygen was almost entirely absent. This oxygen-poor environment allowed another potent greenhouse gas, methane, to persist for far longer, trapping what little warmth the young sun provided. It was in this alien world, bombarded from above, shrouded in a toxic sky, and warmed against the cold of space by its own poisonous breath, that the first, most profound chemical reaction was set in motion. The transition from inert matter to a living being. A process that, once begun, would transform not just the oceans, but the very air and rock of the planet itself. A thick veil of greenhouse gases shrouds the nascent planet, a crucial blanket that traps the warmth of a sun still faint and cold. This atmospheric shield allows for a miracle. Across the globe, water exists not as ice, but as a vast liquid ocean. The stage is set. Within these primordial waters, the first cells stir, and the oceans become a cradle for the first bacteria. In the shallow coastal zones, clinging to the shifting boundary between the tides, vast colonies of cyanobacteria begin to thrive. The land itself is alien. A barren, silent vista, eerily reminiscent of the frozen landscapes we see today on Saturn's moon, Titan. Then a revolution. Countless cyanobacteria develop a new chemistry, a way to harness the ephemeral energy of sunlight. They draw in the carbon dioxide that saturates the air and, in doing so, build extraordinary living structures, stromatolites. Layer by painstaking layer, these cultural legacy of microscopic life. Within these living rocks, a complex society exists. Cyanobacteria on the sunlit surface, other photosynthetic bacteria just below, and deep in the darkness, anaerobic life that shuns the light. The process is elegant, using solar radiation to transform water and carbon dioxide into carbohydrates, a storable form of energy. But this transformation generates a waste product, a volatile, corrosive gas, oxygen. 3.5 billion years ago, this gas was a deadly poison to almost all life on Earth. Survival demanded adaptation. Some organisms evolved not just to tolerate this poison, but to incorporate it into the very heart of their metabolism. Yet the oxygen forged in these shallow seas does not immediately escape into the sky. For an entire billion years, it is captured. The oceans are rich with dissolved iron, and as the first puffs of oxygen are released, they react, binding with the iron and precipitating to the sea floor as rust. Eon after eon, the world's oceans are scrubbed clean, laying down the vast bands of iron oxide that would one day fuel our own civilizations. While the seas are slowly rusting, a new force begins to shape the planet's surface. The first continents are being born, not in fire, but in the deep. The engine of plate tectonics has ignited. Over 300 to 400 million years of oceanic activity, immense underwater plateaus are constructed, a progressive pile of lava reaching thicknesses of up to 50 kilometers or 30 miles. The sheer weight of these formations presses them down into the molten mantle. But the laws of isostasy demand a balance. The less dense plateau is pushed inexorably upwards, breaking the surface of the waves for the very first time. The world is a place of extremes. The atmosphere, rich in methane and carbon dioxide, generally maintains a warm, temperate climate. Yet even this powerful greenhouse effect is not absolute. The planet is poised to experience one of its first great chills, the Pongola glaciation. The Earth is not a passive stage on which life performs. It is an active participant. The planet is being terraformed from within by its own inhabitants. The waste of one epoch becomes the very breath of the next, and the slow, relentless churn of the deep earth forges the ground upon which all future worlds will be built. 2 billion years have vanished since the Earth's fiery birth. On this alien world, a day lasts a little more than 12 hours, and the year is a dizzying 714 days long. This immense primordial chapter, together with the eons before it, represents 85% of our planet's entire history. During its formation, the planet's elements had segregated, some drawn to the metallic core, others rising to the lithospheric mantle. A restless engine of plate tectonics churned the surface, providing novel conditions of temperature and pressure. In these ancient terrains, 1,500 distinct minerals could be found. But a new force was stirring, one that would rewrite the very chemistry of the world. Life. Its quiet exhalation, oxygen, began to offer new possibilities. Minerals that outcropped on the surface were transformed, oxidized in a key step for the mineral kingdom. A great diversification was unleashed as 2,900 new minerals appeared. Life itself began to produce its own specific minerals, eventually painting the landscape with a palette of 4,400 varieties. The planet's geology was also in flux. For eons, the surface had been shaped not just by horizontal shifts, but by vertical movements. Ultra-hot magmas known as komatiites would erupt, cool, and grow dense upon the crust. Pulled down by gravity, these heavy rocks would sink, sculpting the world in 3 dimensions. But 2.5 billion years ago, the komatiites vanished. The vertical tectonics ceased. From then on, only horizontal movements would remain, and the Earth would produce entirely different kinds of rock. For millions of years, the concentration of oxygen had been slowly, imperceptibly increasing, yet it remained in minute quantities, a trace gas in a methane-rich sky. Then 2.4 billion years ago, the world reached a tipping point. It would be known as the Great Oxidation Crisis, a planetary catastrophe. The oxygen produced by the photosynthesis of cyanobacteria had, until now, been captured, reacting with the vast quantities of iron dissolved in the oceans. It accumulated neither in the water nor in the air. But now, the marine iron was depleted. The sinks were full. Oxygen, for the first time, saturated the seawater and breached the surface, flooding the atmosphere. Its concentration surged from less than 1,000% to nearly 20%. For the anaerobic organisms that had dominated the globe, this was an ecological crisis of unprecedented scale. The new air was poison. This oxygen reacted with atmospheric methane, a powerful greenhouse gas, causing its concentration to plummet. A decrease in these levels led to a sharp decline in the greenhouse effect. The planet's thermostat was broken. Changes in sulfur isotopes from this era point to this early stealthy oxygenation and to the cataclysm that followed, a cooling that triggered a succession of glaciations, the Pongola, the snowball Earth. The world plunged into a deep freeze. It was a profound transformation, an apocalypse for the old world. Yet, it was this very crisis, this poisoning of the skies, that would pave the way for the first multicellular life, and eventually, the first animals. Life had not merely inherited the earth, it had remade it, element by element, breath by agonizing breath. 2.4 billion years ago, the planet was undergoing a profound and dangerous transformation. The very emergence of life, a fragile new force, had begun to re-engineer the atmosphere itself. As photosynthesis took hold, the air filled with a corrosive, unfamiliar gas, oxygen. This new chemistry set in motion a planetary chain reaction. Carbon dioxide, the world's thermal blanket, was systematically stripped from the sky, locked away within vast new formations of limestone. This dramatic reduction in greenhouse gases began to cool the globe. The Sun, a much younger and fainter star, offered only 85% of its current energy, providing little defense against the encroaching cold. Temperatures plummeted. On the surface, the climate plunged to -50 degrees Celsius, a staggering minus 58 degrees Fahrenheit. For tens of thousands of years, the world froze. Water turned to ice. The brilliant white surface reflected the sun's weak rays back into space, a phenomenon known as albedo, which only accelerated the freezing. From pole to pole, the oceans were entombed in a shell of white. It was not merely an ice age, it was a planet in suspended animation. Earth had become a snowball. While the surface appeared catastrophic, perhaps irreversible, the planet's molten heart remained defiant. Deep beneath the frozen crust, volcanoes, the world's primordial furnaces, continued to vent gas. For millennia, carbon dioxide accumulated under the ice, a pressure cooker on a planetary scale. Eventually, the breaking point was reached. The gas erupted into the atmosphere, triggering a runaway greenhouse effect. The world began to warm. What followed was a period of deglaciation as violent as the freeze that preceded it, a cycle of ice and fire that would repeat itself 4 times over a span of 300 million years. This climatic upheaval played out upon a constantly shifting stage. The Earth is a sphere in motion, its tectonic plates engaged in a slow titanic dance known as the Wilson cycle. Continents are born only to drift, collide, and tear themselves apart. Around 2.2 billion years ago, the world's primitive land masses coalesced, forging the first great supercontinent, Columbia. It was a colossal entity, stretching nearly 13,000 kilometers from north to south, and almost 5,000 kilometers across at its widest point. For 600 million years it dominated the globe, but no earthly empire is eternal. A continental rift began to form, a scar that widened with immense magnetic activity until, after a few 100,000 years, Columbia was no more. The fragments drifted for an age until 1.1 billion years ago they were drawn together once more. From the wreckage of Columbia, a new supercontinent was born, Rodinia. Forged in the collision between the ancient cores of North and South America, it comprised nearly all the continental land on the planet. Surrounded by a single global ocean, Rodinia was a vast rust-colored desert plain, a world of accumulating sands under an alien sky. The story of our world is one of violent cycles and epic scales, a narrative written in ice and fire, of continents assembled only to be scattered. It is a constant reminder that the ground beneath our feet is not a fixture, but a fleeting arrangement in an endless planetary ballet. The only constant is transformation itself. In the shallow seas of a primordial world, life's first architects are at work. Vast colonies of bacteria build upon themselves, layer by mineral layer, etching living structures of stone, the stromatolites, into the permanent record. But all life remains a prisoner of the oceans. Above the waves, the atmosphere offers no sanctuary. It is a thin, raw veil, lacking the oxygen needed to forge a protective shield of ozone. Deep within the planet, an ancient rhythm dictates the fate of the surface. The continental masses are in constant grinding motion, colossal rafts adrift on a sea of molten rock. For hundreds of millions of years, they had been locked together in a single supercontinent, Rodinia. But beneath this immense planetary blanket, the Earth's inner furnace cannot breathe. Trapped heat accumulates, a colossal pressure building in the upper mantle and the lower crust. The density of the rock decreases, and it begins to rise, swelling the surface into vast domes. 850 million years ago, a superdome buckles the world. The crust cracks open. Through immense trenches of collapse, magma bleeds out, and over millions of years, water rushes in. In fire and steam, new oceans are born. By 750 million years ago, Rodinia is gone. Its shattered fragments lie scattered near the equator. This new geography triggers a catastrophic chain reaction. As global temperatures fall, ice begins to creep from the poles. These brilliant white surfaces act as a planetary mirror, reflecting the sun's warmth back into space and accelerating the cooling. The planet plunges into a deep freeze. A sheet of ice, over a kilometer thick, smothers the globe. It becomes a snowball Earth. Yet, in the abyss, a flicker of life endures, saved by a profound quirk of physics. As surface water cools towards 4 degrees Celsius, it reaches its maximum density and sinks, ensuring a homogenization of temperature through the depths. But below that critical point, a strange transformation occurs. The water becomes less dense. Ice forms, but it floats, creating an insulating shield against the lethal cold above. In the eternal dark, protected from a frozen world, the simplest organisms wait. For eons, life had been held captive by an invisible threat raining from the sky. The very molecules of existence are photosensitive, fragile things, easily shattered by the sun's unfiltered ultraviolet rays. But 600 million years ago, a threshold is crossed. The slow, patient work of photosynthetic life has finally transformed the air itself. In the stratosphere, a new molecule is forged, ozone, composed of 3 oxygen atoms. It is a shield. As this celestial armor accumulates, some 15 kilometers high, it begins to absorb the deadly radiation. The oceans, once a mere refuge, now become a cradle for an explosion of diversity. The planet was no longer just a stage for geology and chemistry, but for biology on a scale never before imagined. The formation of a simple molecule high in an atmosphere transformed by life itself was the permission life needed to finally conquer the land and to build a world beyond the water's edge. Following violent collisions of the Earth's great landmasses, a new supercontinent is born, Pannotia. But its reign is fleeting. In a dramatic phase of tectonic activity, the world continent is torn asunder, a process that takes only a few million years. This evolution, creating new coastlines, new shallow seas, and new opportunities for life. From this planetary upheaval, the marine fauna of the Ediacaran period develops. Around 585 million years ago, the first large multicellular organisms appear. They are a silent, ghostly kingdom. Lacking mineralized skeletons, their soft bodies leave behind only faint impressions, enigmatic shapes of discs, tubes, and quilted feathery bags. Barely 100 species of this strange fauna have ever been identified. They are life's first great experiment in complexity, but it is an experiment of short duration. 40 million years after they appear, they vanish, leaving behind a world on the cusp of another revolution. We enter the Phanerozoic, an eon that continues to this day. On the 24-hour clock of Earth's history, it represents less than the final hour and a half. Yet, what unfolds in this sliver of time is of monumental importance, for it contains the blueprint of our own world. 541 million years ago, the fuse-isogical Big Bang, the Cambrian explosion, entirely new forms of life erupt into existence, giving rise to the great animal phyla that still dominate the earth. A key innovation drives this frenzy of creation, the appearance of hard tissue. Skeletons, shells, and carapaces are forged from the minerals of the sea. This is not merely a change in anatomy. It is the dawn of a new era, an evolutionary arms race between predator and prey, now written in stone. The world itself is in constant motion. The Iapetus Ocean, a vast sea separating the ancient continents of Baltica and Laurentia, begins to close. 530 million years ago, the collision raises a gigantic mountain complex, the Caledonian Chain. Its peaks scar the landscape where northern Europe and America will one day lie. The lands of modern Canada, Greenland, Scandinavia, and Scotland are crushed together in this monumental convergence. The moon hangs closer in the sky, a mere 360,000 kilometers away. Its proximity drives titanic ocean tides which surge and withdraw across the low-lying continents. For nearly all of history, life has been confined to this liquid medium. But 480 million years ago, a decisive threshold is crossed. Humble pioneers, resembling lichens and mosses, begin the conquest of the land. It is a barren, hostile frontier. To survive, they must adopt radical new strategies, developing impermeable cuticles to seal in moisture and ingenious systems to withstand the brutal, desiccating air. For the first time, life takes a breath outside the water, beginning a slow, patient transformation of the planet's silent, empty continents. Every forest that now stands, every creature that walks the earth, owes its existence to these first, tentative steps into a new world. Anchored by tenacious grips, the first pioneers of the land held fast to barren rock, their simple forms a stark contrast to the vast empty continents. In their decay, they laid the very foundation of soil, a gift to the microbial world that would transform the planet. But in the oceans, a deep and ancient rhythm was about to be broken. 445 million years ago, the Earth faced its first great crisis of life. The warm Ordovician seas, once a stable 45 degrees Celsius, had cooled to a life-giving 30 degrees. This new temperate world had become a cradle for a multitude of species, a vibrant explosion of diversification. Then the climate shifted with terrifying speed. A great cooling began, plunging the globe into a profound ice age. As colossal glaciers grew, the level of the seas fell dramatically, draining the shallow coastal waters that had nurtured so much life. For 10 million years, this chill persisted. It was an annihilation, erasing countless marine species, particularly the benthic creatures dwelling on the seafloor, their world vanishing from beneath them. The planet itself spun faster then, a day lasting a mere 22 hours. 400 million years ago, the atmosphere reached a new threshold. Oxygen and ozone levels climbed, forming a protective shield against the harshness of the sun. Beneath this invisible canopy, the first terrestrial arthropods began a tentative exodus from the water. This monumental journey was only possible because the plants had come before them, offering the sustenance needed to survive in this alien world. On land, the rules of existence were rewritten. To find food, animals had to develop new strategies for mobility. To survive out of the water, they evolved internal vascular systems, learning to hydrate by eating and drinking. Yet, for the most vital of acts, reproduction, they remained tethered to the aquatic realm of their ancestors. Around 390 million years ago, a botanical revolution unfolded. Plants engineered a vessel of life, a design that would conquer the globe, the seed. Reproduction was no longer bound to water and spores, but to gametes protected within this remarkable innovation. It was a profound upheaval, freeing the plant kingdom from its dependence on the water's edge, allowing life to march deep into the heart of the continents. But this very success cast a long shadow. The vast new forests drank deeply of the atmosphere's carbon dioxide, triggering another global cooling. In the Devonian period, the world faced a new extinction. As temperatures fell, the oceans were starved of oxygen. 75% of all marine species vanished. The planet's vibrant reef systems, teeming with life, fell silent. Out of the quiet, a new world was born, the Carboniferous. The continental masses drifted together, forging a supercontinent. The first great trees rose in abundance, and a staggering variety of plants flourished in the humid air. In the sprawling swamps and forests, large amphibians thrived, and among them, the first reptiles took their first breath, inheritors of a world repeatedly cleansed by catastrophe. Life, it seems, does not merely advance. It is forged in cycles of ruin and rebirth. Each wave of extinction, however complete, is not an end, but a clearing of the stage, making way for the next act in a drama that has spanned eons, and whose ultimate purpose remains the Earth's most persistent mystery. A new power was rising from the forest floor, microscopic fungi, evolving a novel chemistry, learned to dismantle the very skeleton of the trees. For the first time, lignin, the tough fiber of wood, could be broken down and returned to the air. The planet's immense coal-making engine, which had buried carbon for millions of years, began to slow and then stop. An age of burial was ending. An age of decay had begun. Across the globe, the continents themselves were in motion. In a slow, inexorable collision, the great land masses of Laurasia and Proto-Gondwana ground together, forging a single immense supercontinent, Pangaea. Nearly all the world's land was now one, a vast crescent surrounded by a global ocean, the Panthalassa. In the hollow of this crescent lay the warm, shallow Tethys Ocean. This new geography remade the rules of life. The endless coastlines of the old world vanished, shrinking the vibrant shallow seas where countless species had thrived. In the heart of Pangaea, a continent-sized desert was born, an arid wasteland so far from the ocean that rain rarely, if ever, fell. Then, 258 million years ago, the planet's deep fury began to stir. In what is now China, the Emishan traps erupted. Lava flows, 1 to 2 kilometers thick, smothered 330,000 square kilometers of land. The atmosphere choked on carbon dioxide, water vapor, and sulfurous gas. A veil of particles dimmed the sun, plunging the world into a sudden chill, only to be followed by a brutal, suffocating heat as the greenhouse gases took hold. It was a devastating blow to life. But it was only a prelude. 6 million years later, in the heart of modern Siberia, the Earth bled fire on a scale that defies imagination. Compounded by the earlier eruption and the extreme stresses of the Pangaean world, the effect was apocalyptic. This was the Permian-Triassic crisis, the Great Dying. It remains the most profound catastrophe life has ever endured. On the continents, 70% of all species vanished. In the oceans, the silence was almost absolute, as 95% of all marine life was erased from existence. Entire dynasties of animals, which had dominated the planet for eons, were gone forever. The trilobites, with their intricate exoskeletons, disappeared. The ancient sea lilies and sprawling fern forests were decimated. The slate had been wiped almost clean. 230 million years ago, into this emptied world, a new dynasty would rise. From the few hardy survivors, evolution began to experiment. They were called the dinosaurs. For 200 million years, they would be the undisputed masters of the earth, diversifying into a breathtaking array of forms. They were terrestrial and airborne, bipedal and quadrupedal, hunters and herbivores. Some, weighing up to 100 tons, were the largest land animals the world has. They pioneered fantastic new forms, horns, crests, and an innovation that would one day conquer the skies: feathers. Life had been pushed to the very brink of annihilation, a mere flicker in the face of planetary violence. Yet, from the ashes of one world, it built another, more spectacular than the last. The planet does not merely host life. It is an active and often brutal partner in its unending story of destruction and renewal. In the aftermath of the Great Dying, a profound silence hangs over the globe. Into this void, a new dynasty of reptiles arises. The archosaurs are the first to claim the ecological niches left vacant, their reign beginning on a world scarred and recovering. They are soon joined by herbivores, the first green shoots of a new food web. Across the landmass that will one day become Europe, an alien landscape is forming. The oceans, in a relentless cycle, flood the low-lying plains. As the waters retreat, they leave behind a shimmering ghost of salt. Millennia after millennia, this process repeats, building a salt crust of astonishing thickness, in places several hundred meters deep. This salt, lighter than the rock above it, begins a slow, silent ascent through the geological layers. When the colossal forces of tectonics forge a mountain range, these malleable salt beds are the first to deform, contorting and rising to form the very footing of the new peaks, creating unique structures that will one day trap the planet's hidden wealth of water and oil. From the darkness of space, a new threat emerges. A meteorite, ancient and indifferent, plummets toward the Earth. As it screams through the atmosphere, it shatters, unleashing a barrage of impacts over several hours. One fragment strikes with unimaginable violence. At a speed of 20 kilometers per second, it slams into the planet, vaporizing rock and carving a crater 21 kilometers wide. The shock wave alters the very fabric of the crusted-scapes of Canada, France, Ukraine, and the United States. 200 million years ago, near a shallow coastline in modern-day France, the Rochechouart impactor struck. The collision triggered an earthquake of 8.2 magnitude. It spawned a colossal tidal wave, a wall of water that surged inland for more than 1,300 kilometers, erasing the world it touched. Yet even this cosmic assault was dwarfed by a deeper, more profound change. The supercontinent of Pangaea, which had held the world's land in a single embrace, begins to tear itself apart. North America and Africa slowly drift away from one another, and the Atlantic Ocean is born between them. Two new supercontinents, Laurasia and Gondwana, chart their own separate courses. This planetary reshuffling triggers a cascade of consequences. The vast, arid interior of Pangaea gives way to an oceanic climate. New mid-ocean ridges activate, pushing the sea level ever higher, submerging vast continental shelves. Life, which had just begun to recover, is thrown into chaos. Populations once connected are now isolated by impassable oceans, their genetic paths diverging until they become entirely new species. But this creation comes at a cost. The fracturing of the world causes a massive extinction event. Nearly 20% of all marine species vanish. A great many terrestrial vertebrates disappear forever. From this Triassic-Jurassic crisis, however, new giants emerge. The dinosaurs, already well diversified, weather the storm with remarkable resilience. As the continents continue to split and the climate swings wildly from frigid cold to searing heat, they do not just survive, they thrive. The extinction of their rivals has cleared a stage, and for the next 182 million years, the world will be theirs. The Earth is never still. Its story is not one of gentle progression, but of violent upheaval and radical transformation. The forces that tear worlds apart are the very same that give rise to new ones, and life, in all its fragility, must perpetually adapt to the whims of a planet that is forever remaking itself. A world on edge. Following a vast volcanic episode, the atmosphere thickens with outpourings of methane. The planet's circulatory system, its great ocean currents, begins to fail. The vital exchange between cold, deep waters and the warm surface slows, and the ocean floor is starved of oxygen. It is a small crisis, a tremor before the quake, felt most acutely by the creatures of the sea. Yet, amidst this planetary turmoil, life was innovating in spectacular fashion. On the continents, a revolution was taking shape. Certain species of dinosaurs were cloaked in a new kind of armor, a new language, feathers. More than mere thermal insulation, they became a canvas for communication, a tapestry of colored signals. They became a shield, tenderly protecting the next generation within their eggs. And for some, they became the key to unlocking the sky itself. With this significant locomotor advantage, a lineage of dinosaurs took flight, colonizing new ecological niches, escaping ancient predators, and honing their hunt from above. Beneath their feet, the very ground was in motion. Immense emissions of lava sculpted vast plateaus, announcing the slow, inexorable separation of South America and Africa. Land masses, still fused in a final embrace. 10 million years later, a flood of basalt would pour into the growing rift, the definitive sign of a fracture that would one day become the South Atlantic Ocean. Then, 66 million years ago, the end of an era arrived. In a magmatic province of what is now western India, the earth itself began to bleed. Huge, relentless lava flows, the Deccan traps, piled one on top of the other. Eruption after eruption built sheets of molten rock up to 2,400 meters thick. The repercussions for the global climate were catastrophic. Vast quantities of water vapor, sulfur dioxide, and carbon dioxide choked the atmosphere. The vapor formed a powerful greenhouse blanket. The sulfur fell as acid rain. The world was changing faster than life could adapt. As the planet poisoned itself from within, a new threat arrived from the cosmos. A meteorite, a mountain of rock and ice, pulverized itself against the earth. It carved an impact crater 180 kilometers wide into the land that would become Mexico. Its vaporized components scattered across the globe, a telltale anomaly in the geological record. An immense shroud of dust rose into the high atmosphere, shielding the sun and plunging the world into an almost permanent night, an artificial winter that would last for years. The Cretaceous Paleogene crisis had begun. It was not the most devastating of the 5 great extinctions, claiming only 6% of species on the continents. But for the non-avian dinosaurs, it was absolute. In the oceans, the toll was far worse, with 76% of all species vanishing forever. The extinction event was a profound reset for biodiversity. A silence fell over the planet as entire dynasties disappeared. But in their absence, the world was left open. The field was now free for others, for the small nocturnal mammals that had lived in the shadows of giants, to emerge from the darkness, to diversify, and to develop. Extinction is not merely a conclusion. It is a violent clearing of the stage, a brutal form of creation that makes way for the most improbable of successors to inherit a transformed world. The world of ammonites and ancient reptiles did not fade. It was shattered. A brutal transition that cleared the stage for a new dynasty of life, the age of mammals. This planetary upheaval began with the groaning breakup of a supercontinent. Pangaea, once whole, tore itself in two, forming Laurasia to the north and Gondwana to the south. Within Gondwana lay a fragment of land, a future subcontinent destined for an extraordinary journey. Powered by the deep heat of the Earth, a plume of volcanism ripped this landmass from its South American anchor. For a time, a shallow seaway separated them, but its destiny lay elsewhere. This was the birth of India. 65 million years ago, adrift in the vast Tethys Ocean, the Indian plate passed over another volcanic hotspot. This infernal engine supercharged its voyage, accelerating its relentless push northward toward the mass of Asia. The collision was not an event. It was an epoch of violence, a slow-motion cataclysm, buckling the crust of the earth, thrusting the seafloor of the Tethys skyward. On the surface, the planet gave birth to the Himalayas. In its depths, under unimaginable pressure, the impact reverberated through the global climate. The planet plunged into a crisis, a series of hyperthermal episodes, the most severe of which is known as the Paleocene-Eocene thermal maximum. Vast stores of methane hydrates, frozen within ocean sediments, were destabilized by the planetary fever. They erupted into the atmosphere, triggering a runaway greenhouse effect. The deep oceans, usually frigid, warmed by 5 degrees Celsius, reaching a temperature of 10 degrees. The Arctic, once a temperate region, became tropical. Its waters hovered around 23 degrees Celsius, its air a balmy 20 degrees. This profound warming shattered the planet's carbon cycle and unleashed a biological crisis. In the ocean depths, about 40% of all benthic foraminifera species vanished forever. Yet, in the crucible of this hothouse world, new life emerged. The major orders of modern mammals appeared, seizing their chance. And in the sweltering humidity, colossal reptiles made a final stand. Titanoboa, a serpent weighing more than a ton, thrived in a world remade by fire. As India crumpled into Asia, other forces were tearing the world apart. In eastern Africa, the Arabian, Nubian, and Somali plates began to pull away from one another. The ground split open, forming the Great Rift Valley, a network of collapsed furrows stretching over 6,000 kilometers long and 50 kilometers wide. The collision of India sent shockwaves through the Asian continent. Entire continental blocks were ejected sideways. Great faults propagated deep into the heartland, driving 2 immense pieces of land out toward the Pacific. Millions of years later, these fragments would form the peninsulas we know as Malaysia and Indochina. To the south, the tectonic dance opened new gateways in the ocean. The Drake Passage cleaved South America from Antarctica. The Tasmanian Passage separated Australia from the frozen continent. 35 million years ago, as these rifts deepened, a mighty ocean current was born, the Antarctic Circumpolar Current. It was a wall of cold water, forever circling the southern pole, thermally isolating Antarctica from the rest of the world. This, combined with a gradual decrease in atmospheric carbon dioxide, began a final, dramatic transformation. The last great greenhouse faded, a continent began to freeze. The Earth is not a static stage, but a dynamic, violent, and creative force. It builds mountains from oceans, carves valleys with fire, and in its fever, it both extinguishes worlds and gives birth to new ones, a relentless cycle of destruction and renewal written in stone. 24 million years ago, the Earth is a world in violent flux. Deep beneath the waves, where northern Europe and Greenland were torn asunder 30 million years earlier, a new land is being forged in fire. This is Iceland, the visible peak of a colossal underwater mountain range, a landscape of 3,000 to 4,000 meter titans rising from the abyssal plain. Here, the planet's inner furnace breaks through, emptying vast magma chambers in cataclysmic eruptions, leaving behind the collapsed gaping wounds known as calderas. Half a world away, another monster slumbers. 17 million years ago, the relentless drift of the American plate carried it over a deep mantle hotspot, giving birth to the Yellowstone caldera. It is a scene of almost unimaginable eruptions, a supervolcano, where the planet still vents its furious heat in geysers of steam and boiling water. And yet, even in this toxic, superheated realm, life finds a way, organisms clinging to existence in the most extreme of conditions. Amidst this geological turmoil, a different story begins to unfold. 7 million years ago, the oldest hominid yet known walks the earth. We call him Tumai. More than 350,000 generations separate his world from ours, a chasm of time almost too vast to comprehend. The silence of the ages is broken again 3.2 million years ago with a discovery that will change everything. From the Ethiopian dust, a skeleton emerges, 52 precious bones. They belong to a female Australopithecus, a creature we will name Lucy. She was young, perhaps only 20 years old when she died. She stood barely 1.1 meters tall and weighed a mere 25 kilograms. Her bones tell a story of a life lived between two worlds. Her skeleton whispers of bipedalism, of walking upright across the savanna, yet her form retains an aptitude for life in the trees. Once hailed as the direct ancestor of modern man, she is now seen as a cousin, a vital branch on our sprawling family tree, but not the trunk itself. Then, the planet's climate shifts dramatically. 2.6 million years ago, the Quaternary era begins. It is our era, the most recent tick of the geological clock, an age defined by ice. At least 17 great periods shall spring. This relentless succession of climate change becomes a brutal engine of evolution, driving cycles of extinction and recolonization, forcing species to adapt, migrate, or perish. Immense ice sheets form on the continents, grinding and scouring the very bones of the land, carving the landscapes we know today. As the world cools, the map itself is redrawn. The Isthmus of Panama rises, stitching together two continents that had been separate for eons. What follows is the Great American Interchange, a vast biological experiment. Porcupines, anteaters, and armadillos surge north. Horses, deer, and ancient elephants move south. For a time, the exchange seems balanced. But after 1 million years of mobility, a harsh verdict is rendered. The northern mammals continue to thrive and push southward, while the southern pioneers dwindle, their lines fading into extinction. Today, only 10% of northern mammals have southern roots, while fully half of all southern fauna can trace its ancestry to the invaders from the north. And it is on this stage, a world of ice, of shifting continents and fierce competition, that a new protagonist appears. A different kind of bipedal hominid, distinct from the Australopithecines still roaming the earth. This is the genus Homo. 2.4 million years ago, in Africa, the first representative emerges, Homo habilis, the handyman. With this species, a new branch of life begins, a lineage that will not cling to the trees, but will instead take up stone, shape it with intention, and begin a journey that will eventually carry it across every continent on the planet. This was not a gentle dawn, but a birth forged in the crucible of a changing world, a new consciousness flickering to life against a backdrop of immense and indifferent power. On the vast stage of Africa, new forms of humanity took their first steps. Homo rudolfensis and Homo ergaster. Names whispered from a time before memory, their stories bound entirely to their native continent. Far beyond, across the sprawling landmass of Eurasia, another would emerge, Homo neanderthalensis. Though separated by geography and millennia, they were united by a revolutionary destiny. They walked with a constant bipedal gait. Their skulls expanded, housing minds of growing complexity, and within those minds, the first sparks of culture began to glow. In the careful treatment of their dead, in the first tentative artistic creations. With just 10 seconds remaining on our planetary clock, a new protagonist appeared. Homo erectus. Born in Africa, this was a species defined by restlessness. They would not be contained, pushing out to conquer a vast portion of Eurasia, reaching as far as the islands of Indonesia. They constructed the first deliberate shelters, and the stone in their hands was shaped with ever-increasing skill and purpose. They were a turning point in the human lineage, a people of profound adaptation, molding their existence to the demands of the land. Long before it was tamed, fire was a wild element, a gift of lightning. For ages, these early humans would have used it opportunistically. But by 1 million years ago, they had learned to command it. The flame became a collaborator. It transformed the hunt, cooking flesh to release new sustenance and destroy lurking pathogens. It became a weapon, a flickering shield against the predators of the night, and a tool of power between rival groups. And in its warmth and light, it pushed back the darkness, creating a circle of security, a focal point for the very beginnings of social life. Yet, with only 6 seconds left, the era of Homo erectus drew to a close. Despite their great innovations, their capacity to adapt was ultimately outpaced by the relentless pressures of a changing world. Their journey on Earth was over. As they faded, another branch of the human family tree grew strong. First appearing in Europe over 250,000 years ago, the Neanderthals would come to occupy all of Eurasia. They were physically distinct, shorter, more massive, their bodies powerfully built for a harsh and unforgiving climate. A heavy ridge of bone sat above their eyes, their foreheads receded, and they lacked the prominent chin that would define their successors. Yet The size of their brain, even larger than our own, gives no indication that their intellectual world was any less rich. They were not a primitive caricature, but a parallel humanity, successful for hundreds of thousands of years. And they left an indelible mark, bequeathing to us, modern humans, a portion of their genetic heritage, irrefutable proof that our ancestors were once close enough to create new life together. Then, with 5 seconds to midnight, the final actor arrived. Homo sapiens, our own species. We are now the sole surviving representatives of the entire Homo genus. Our physiology is different. A high, rounded skull, a face without the heavy brow ridge, a delicate but jutting chin. Our commitment to walking on 2 legs is absolute, but the true distinction lies deeper. It is found in the intricate web of our social relations, in the unparalleled complexity of our articulated language, in the impulse to create clothing, and in the ambition to domesticate nature itself. This new human was an explorer without equal. We poured across the continents, mastering every environment, leaving only the frozen wastes of Antarctica untouched. And over 100,000 years ago, a profound new behavior emerged. We began to bury our dead with intention, a clear sign of abstract thought, of grief, and perhaps of a belief in a world beyond this one. The story of humanity is not a straight line, but a sprawling, tangled tree of ancestors and cousins, of encounters and extinctions. We walk the earth today as the last of our kind, carrying within ourselves the faint genetic echoes of those who came before, the sole survivors of a family saga millions of years in the making. A profound shift occurs in the human story. The dead are no longer merely discarded. They are buried with intentional care. From the scarcity of these early graves, we can infer a deliberate selection. Not all were granted this final reverence. Paradoxically, this new ritual of interment hastens the decay of ancient skulls, which had previously been kept within living spaces, surviving the ages in far better condition. While early humans looked inward, contemplating mortality, the cosmos delivered a reminder of its own power. A fragment of iron, a mere 20 meters across, tore through the atmosphere and struck the Earth in what is now Arizona. It impacted at 50,000 kilometers per hour, releasing a colossal energy. 150 million tons of rock were vaporized and ejected, scattered across 260 square kilometers. The shock wave annihilated everything within a 15-kilometer radius. Yet, within a single year, life would begin its patient reclamation of the scar. The fate of the Neanderthal remains one of prehistory's great enigmas. One hypothesis suggests a slow decline, beginning with the arrival of modern humans, the Cro-Magnon. A bitter competition for territory and resources erupts, leading to violent conflict. It is here that a new alliance may have sealed the Neanderthal's doom. The domestication of the dog by Homo sapiens coincides with their cousin's disappearance, granting our ancestors a lethal advantage in the hunt for food. As the last great ice age of the Quaternary recedes, the world blossoms. Flora and fauna flourish, and in this new abundance, some human populations cease their wandering. They settle, turning their ingenuity to ceramics, pottery, and the revolutionary practices of agriculture and animal husbandry. The first great cradle of this new world emerges in the Fertile Crescent, a lush region fed by the Jordan, the Euphrates, the Tigris, and the Nile. With stockpiles of grain came the birth of complexity, of hierarchy, of organized society. The planet itself was still in flux. 9,000 years ago, the Bosphorus Strait was violently torn open, connecting the continents of Asia and Europe. The salt waters of the Sea of Marmara cascaded into what had been a vast freshwater lake, transforming it into the Black Sea we know today. To the south, an even greater transformation was underway. 6,000 years before the Common Era, the Sahara, now the world's largest hot desert, was an almost unrecognizable landscape. Across its 8.5 million square kilometers stretched a gigantic tropical savanna. Gazelles, hippos, and elephants drank from sprawling lakes. This was the last great green episode of the Sahara, a wet African period fueled by the abundant rains of an interglacial peak. But this verdant paradise was fleeting. Beginning around 5,500 years before the Common Era, the climate began to shift. The rains grew scarce, the lakes receded, and the green savanna began its inexorable march into sand. The earth remembers what we have forgotten. Beneath the craters, the seabeds, and the endless dunes lie the ghosts of lost worlds, each a silent testament to the planet's ceaseless and indifferent transformation. A sea of sand advanced, swallowing a green world. As the Sahara expanded, tropical species yielded to creatures of the arid expanse, a slow, inexorable conquest by the desert. In the fertile crescents of civilization, a different challenge arose. With the growth of agriculture and trade, human memory, bound to the present moment, proved insufficient. A system was needed to hold the past, to secure the future. In this crucible of necessity, writing was born, drawing a profound line between what was and what would be remembered. History had begun. It was in Mesopotamia, the land cradled between the Tigris and Euphrates rivers in the heart of modern-day Iraq, that the first evidence was found. Around 3,500 BC, on humble tablets of clay, merchants noted the names of owners and the quantity of their goods. This was not a language of letters, but of things. Pictograms and ideograms, direct representations of the world. Over centuries, the Sumerians refined this art, their reeds pressed into clay, creating a script of interlocking wedges, a system known as cuneiform. The abstract had triumphed over the literal, yet it would not be until the 14th century BC that a single sign would finally correspond to a single sound. While Mesopotamia carved its records in clay, other peoples were developing their own systems of memory. Along the Nile, the Egyptians sketched their world onto rolls of papyrus and leather. Theirs was a vibrant, figurative script of hieroglyphs, a pantheon of plants, animals, and divine figures, frozen in time. Here, life was governed by the great river. Subjected to the annual life-giving flood of the Nile, the Egyptians sought to predict its rhythm. They observed that the deluge began on the day the sky's brightest star first appeared in the glow of the rising sun. This became the first day of their year, a year divided into 3 seasons, a calendar designed to master time and command a harvest. Though imperfect, this celestial clock would measure out millennia before being reformed by Julius Caesar. Far to the north, on the plains of what is now southern England, another monumental effort to chart the heavens was taking shape. At the site of Stonehenge, a sanctuary, a tomb, and an astronomical observatory were being raised. In the year 2400 BC, its first great stones were heaved into place, forming a perfect circle 33 meters across, within a larger earthwork 108 meters in diameter. It was a silent calendar of stone, using cosmic alignments to track the sun's journey through the sky. But while humanity sought to impose order upon the world, the earth itself held a power that defied all calendars. 3,600 years ago, in the Aegean Sea, the volcano of Santorini stirred. After a slumber of barely 100 years, it awoke with unimaginable violence. The explosion hurled 60 cubic kilometers of magma into the sky, a fiery cloud of pumice and ash that rained down over 900 kilometers away. The island was obliterated, the volcano collapsing in on itself, its fury echoing across the ancient world. From clay tablets to stone circles, from the rhythm of a river to the path of a star, the impulse is the same. It is the eternal human struggle to create permanence in a world of cycles and cataclysms, to etch a fleeting existence into the memory of the earth itself. The earth tears itself open, a caldera collapses, and a gigantic tsunami scours the eastern Mediterranean. Long before we had a name for such power, we knew its fury. Centuries later, in the year 79, Mount Vesuvius awakens. At first, immense explosions erupt as water meets magma, vaporizing in an instant. Then the mountain's throat of solid lava is pulverized, ejecting a column of fragments more than 30 kilometers into the sky. Every hour, 15 centimeters of ash and pumice stone accumulate, a suffocating gray snow, until the column collapses under its own weight, roaring back to earth in a pyroclastic cloud. The cities of Herculaneum and Pompeii are erased. From their ruins, a new word is born to name the terror: volcano. In the year 1257, on the island of Lombok, Mount Sarmalus erupts in what remains the most devastating volcanic event in recorded history. Its ash veils the sun, reflecting its rays back into space. Global temperatures plummet, and a brief, brutal cooling brings famine and hardship to populations across the world. While the ground beneath humanity's feet proved violently unstable, our conception of the heavens was, for millennia, one of perfect, immovable order. Yet in 400 BC, a lone thinker dared to dissent. Philolaus of Crotone, astronomer, mathematician, philosopher, proposed a radical cosmos. He saw the Earth not as a fixed center, but as a planet, rotating around a great central fire, an entity distinct from the sun. Around this same fire, he argued, orbited the sun, the moon, and the 5 visible planets. It was the first tremor in a revolution of thought. That revolution would finally arrive in 1543. After centuries of a geocentric model, a new philosophy, a new scientific method was poised to shatter the old world. A book appeared, On the Revolutions of the Celestial Spheres, by Nicholas Copernicus. Though completed 13 years earlier, fear of the church and the state had delayed its publication. Its novelty was profound, its implication terrifying. Copernicus placed the sun at the center of the system and set the planets, our own Earth included, in motion around it. The Copernican revolution forever altered our representation of the world, dislodging humanity from its privileged center and recasting us as wanderers in a universe of physical laws. The Earth continues to move. On May 22, 1960, a mega-earthquake strikes Valdivia, Chile. Its magnitude is 9.5, the highest ever recorded. The Nazca Plate slides beneath the Chiloa block, a sudden catastrophic slip of about 18 meters or 60 feet. The ocean floor heaves upward by 6 meters, unleashing a tsunami that devastates the Chilean coast before racing across the entire Pacific Ocean. It reaches Hawaii as a wall of water with waves 10 to 12 meters high, bringing ruin to shores thousands of miles from its origin. We spent an age believing we were the still point of a turning world, only to discover we inhabit the thin, fragile crust of a fiery planet, itself a mere speck in a silent cosmic dance. The stability we crave is an illusion, dwarfed by the colossal, indifferent mechanics of the universe. Forces that operate on a scale far beyond our comprehension, reminding us that we are not masters of our world, but merely passengers. The wave travels outward, a liquid wall of immense energy, striking the coasts of Japan, New Zealand, the Samoas, the Philippines, and the distant Marquesas Islands. Back at its source, the Chilean coastline is irrevocably altered. In the wake of the mega-earthquake, 4,000 lives are lost. 2 million people are left without a home. Then, on May the 24th, 1960, just 2 days later, the planet unleashes another fury. The Cordon volcano, nestled deep in the Andes, erupts after more than 25 years of inactivity. 200 million cubic meters of lava bleed across the landscape, while 60 million cubic meters of tephra are violently ejected into the atmosphere. A world remade by fire and water. Today, this world remains the 5th largest planet in our solar system. It completes its journey around the sun in 365 days. Its axis of rotation, inclined at a precise 23 degrees, orchestrates the grand parade of the 4 seasons. Far above, its only natural satellite, the Moon, keeps its silent watch from a distance of 384,000 kilometers. The tectonic plates that form the very ground beneath our feet continue their slow, inexorable dance, shifting a few centimeters each year. 71% of the surface is covered by water, a vast network of oceans, lakes, and rivers. Its polar regions lie dormant, largely entombed in ice. Upon this fragile stage, more than 7.9 billion people now live, each one dependent on the planet's finite natural resources. The evolutionary history of life has never been a gentle story. It is a tale punctuated by periods of explosive expansion and devastating mass extinction. It is why 99% of all species that have ever existed on Earth are now gone. The history of our planet is not a long, quiet river. The forces of nature offer no respite, constantly disrupting whatever equilibrium has been established. But today, a new force has been added to the equation. Human activity now rivals nature itself, driving a staggering loss of biodiversity, a deepening climate crisis, and profound ecological imbalance. Where humanity was once a mere pawn, subject to the whims of geological phenomena, its activity now holds a decisive influence over the future of the planet. The story of Earth is not over. Its continuation seems impossibly long, and even if our knowledge allows us to predict certain events, the narrative will always contain the unexpected. We have become a geological force, yet we remain subject to the planet's ancient, unyielding power.